Hi everyone, today I am going to discuss about my final year project experimental studies on mechanical and microstructural properties of IS2062. Here is the content which states about all the processes. And IS2060 is a product of standard of Bureau of Indian Standards. It is mainly hot rolled medium and high tensile structural steel. Here we have done some processes like heating, bending, quenching, magnetic particle testing and Rockwell hardness testing, etc. It is mainly classified into 9 grades with respect to quality. Its main properties are wood formability, weldability, etc. These are some of the physical properties, and this is the chemical composition of IS2062, which has 0.23 of carbon content. And here it is the applications of IS2062, which is aerospace, nuclear power, chemical, oil and gas, refinery, etc. Here are some typical applications of IS2062, particularly grade B, which is used in shipbuilding, mechanical, manufacturing, power plant systems, construction. Here we have taken some literature reviews of some of the authors. Heat treatment and microstructural study magnetic particle test is carried out, and here it is the methodology we have followed, with quenching and without quenching. Selection of structural steel and selection of grade, heat treatment, bending, all those processes we have carried out. And then here are the steps we have followed, like the plate of IS2062 is heated at various temperatures. When it is in hot condition, it is bent into U shape, and then it is followed by water quenching. Here we have heated the specimen at different temperatures like 500, 700 degrees centigrade, 900, 1100, and we have bent that specimen into U shape using mechanical pressing machine of capacity 5 ton Pascal. Coming to result and discussion, at first the specimen as shown in the figure are cleaned to remove rust. Then it is heated at various temperatures, as I said earlier. Each specimen is heated for 2 hours, and the capacity of the furnace is about 1600 degrees centigrade. Then specimen are taken out from the furnace and bent using mechanical pressing machine of capacity 510 pascals, and it is bent at an angle of 63 degrees. Here are the pictures of bent sample, and later we quenched the samples at different temperatures like 5, 7, 9 and 1100 degrees centigrade shown in the figure. You can see the bent sample, and later we have carried out that microstructural study on both air cooled and quenched specimens. Here you can see martensite, austenite and ferrite. The dark is martensite, and white is ferrite. It is separated, both are separated by austenite boundaries. Here you can see the specimens under microscope at 500 and 700 degrees centigrade, and then 900 and 1100 degrees centigrade. As you can see the difference. Later we have performed Rockwell hardness test. Here you can see tabulation and results. As you can see, we have taken for both air cooling and water quenching, and we took average of all. And from the table it is very clear that the hardness varies with temperature. Is carried out Rockwell hardness test is carried out because of its robustness. And here you can see the dimensions of the plate of IS2062. And this is the cost of our project. And conclusion. Finally, in heat treatment process, the hardness of material vary with various temperatures. That is, hardness of the metal plate decreases at high temperatures due to grain refinement. From the experiment, it is clear that the RHN number decreases first and then increases with respect to increase in the temperature for both air cooled and water quenched specimens. The microscopic structure is carried out to analyze the grain refinement. It's been observed that there is a significant change in the structure of each specimen. The bright space in the microscopic image is ferrite, dark is martensite, and the boundaries are austenite. Here the bending is done on particularly 63-degree angle. The bend can be changed and experimental outcomes can be observed. Here you can see some references we took And here is the time chart. As you can see, final view. Thank you. That's it.